Alright, so this is the video lesson for 4.2. This is notes on logs and also some review of exponents. Okay, so let's start out with exponents. We have y equals a to the power of x. This is just a very basic exponential function where a is a number other than 0 or 1. And this would also include the natural number now, which has a lot more applications. We already saw that in 4.1 notes. Okay, so let's think about a number that's not 1 or 0, okay, because those numbers would yield very simple results. But if you have a number and you're taking it to the power of x, you're either going to have growth or decay. Now, do you remember how to look at the a and know if it's growth or decay? If it's a number larger than 1, if a is larger than 1, you're going to have growth. If a is a fraction, number between 0 and 1, you're going to have decay. Let's go ahead and just do the growth function for right now. This is going to make it easier than to compare to the log function. So here we have where at 0, at x equals 0, all right, we have a y-intercept at 0, 1, and then we also have an asymptote at y equals 0. Okay, this is a one-to-one function. If you remember that, it is a function, and we're going to see in a second that its inverse is a function, but we can even know just by looking at this graph by using the horizontal line test that its inverse is also a function. The domain is going to be all real numbers. The range, though, is going to be all the numbers greater than 0, and we've covered this with parent functions. We're going to have from 0 to infinity. Okay, parenthesis, not bracket. All right, now for logs, I'm going to switch colors up here. Remember, if these two things are inverses, what we would do is we would switch x and y. So we would have x equals a to the power of y. Now, with logs, we can, there's several different ways we can simplify this that I'll go into the notes today and through the next several days. But you can rewrite this as a log. You can take log of both sides. You can take natural log of both sides. But this right here is the same as saying y equals log base a of x. These two things are the same statement. The base of the exponent is the base of the log. Okay, so log base a of x equals the exponent y. All right, now this should be inverse here. So I'm going to have a vertical asymptote. And logs are one of those things that they have tons of applications, but it's a system, not like a system of equations, but it's a framework to solve exponential problems, and there are more things you'll learn about in calculus that you can do with them. All right, so if you get confused about what is a log, it's just an inverse of an exponent. That's all you need to know for right now. Okay, our point at 0, 1 now becomes 1, 0, and we're going to have a reflection across the line y equals x. Okay, so these two things are inverses. I've said this, but I'm going to keep saying it. That's important to know here. All right, so this is also one-to-one. All right, now let's discuss domain. Domain, we can just look at the graph and see that the domain is all the numbers greater than 0. That's interesting. That was the range of the exponential graph. Okay, the range of the log graph is going to be what was the domain of the exponential graph. The domain and range have exactly switched, and when you have true inverses, this happens. This is why when we were doing inverses of a quadratic to a square root or square root to a quadratic, we had to put that stipulation on the domain, on the x values. All right, let's talk about this statement. I've already written this down, but if x equals a to the power of y, then y is going to equal log base a of x, okay? And I'm going to even write here that if x equals e to the y, then y is going to be equal to natural log of x. Remember, natural log is just log base e. That's all that is, where e is the natural number. In natural log, eventually you'll use natural log more than this log right here, okay? This right here just means both ways. It means that this is true and the inverse is true. If, then if. Okay, so let me write a statement down here. Log base 2 of 8 equals 3. This is a true statement. All right. Another way I could have written this is I could have written 2 to the power of 3 equals 8. Now this is a statement we're more familiar with. We know that 2 cubed is 8. So log base 2 of 8 is 3, and there are other ways I can even write this statement. All right, but we're going to leave it as it is for right now. Let's say you were working on a problem where instead of 2 cubed equals 8, or let me back up. Let's just say that if we had an equation and it was log base 2 of 8 equals x, and you had to solve for x. Now, we already know the answer is 3, but let's think about how you would solve for this. Probably the easiest way on this problem is to think 2 to what power gives you 8. And if that's a whole number or even just a simple fraction, then that's the easiest way to solve it. We're going to have a whole day just of solving logarithms. So we're just going to do easy ones for right now. If I give you, though, something more complicated, like this, or let me back up. Let's say I gave you an exponential. That's more complicated. Now, 2 to some power does not equal, I mean, we can estimate that it probably has to be a little bit less than 3, all right? But I don't know what it is exactly. This is where we're going to have to do more to find the answer. We're going to have to use the calculator, probably. And there are many different ways we can do it, and that's a whole nother lesson. But this is where the use of logs is going to help us on a problem like this. Okay, so now let's just do some simple evaluating. So we're saying 3 to what power gives you 27? And these you should know. We're not going to go through, and that's 3. 3 cubed is 27. I'm not going to go through and have you memorize this and do a quiz. You did that last year. You should still have most of these memorized. Maybe not some of the more obscure ones, but basic ones you should. All right, this one's a little bit harder. 16 to what power is 4? Now, 4 squared is 16. So 16 to what power is 4? Well, we got to think, well, what's the opposite of square? That's square root. And what's the power on a square root? That would be 1/2. Okay, so let me write this underneath here. 16 to the 1/2 power is 4. And that's because the square root of 16 is 4. 1/2 power square root. 1/3 power would be the cubed root. Okay, again, this gets a little bit harder. We're thinking 7 to what power gives us 1/49? Well, I know that 7 squared is 49, but 1/49, this is going to, we need to make that power negative. Okay, so this is equal to -2. All right, so these are just ones you can do quickly in your head. With practice, for sure you can do it quickly in your head. We do need to practice it a little bit, and we will in class tomorrow. Okay. Let's just make sure we understand the difference between these phrases. Common log and natural log. Okay, common log is log with base 10. Now if you think about base 10, it's important because scientific notation is in base 10. There's some applications where you would want to use base 10 because we're using, exponentials with powers of 10. Natural log, though, is going to have a lot more applications. This is log base e. All right, which we call ln, or natural log. This is not ln, it's not ln, it's not even ln, it's natural log, and that's what we're going to call it in this class. Okay, but it's the same as log base e. We're not going to do a whole lot, maybe a little today, but we're not going to do a whole lot with logs of other bases. Maybe just to practice, but in application, you're going to use one of these two. Okay, your calculator, by the way, if you just type the log button, it assumes log base 10. In tomorrow's lesson, we're going to talk about change of base so that when you do have a log of a different base, you can change it either to log base 10 or log base e. Okay. All right, I'm going to write some problems down here, and I want you to think and write it down or pause it and see if you can work ahead of me, if you can figure it out. So what is log of 100? All right, that is 2. That is because 10 squared is 100. You're thinking the base, which is 10. There's no base written. It's assumed to be 10. Okay, so the answer to that one was 2. So let's think about, well, what's the natural log of e? Okay, we're saying e to what power gives you e? Well, that's a 1. Okay, what about natural log of 1? This one's a little trickier. You might remember it. E to what power gives you 1? Well, a number to the power of 0 gives you 1, and this should also make sense because the point 1, 0 was on the graph, which really works for logs of any base, 1, 0. So a log of any base of 1 gives you a 0. Log of 0 itself, though, is undefined. Okay, let's do natural log of 1 over e squared. Remember, we have a base of e. We're saying e to what power gives you 1 over e squared. The 1 over is going to give us a negative, and that's going to give me negative 2. Okay, e to the power of negative 2 is the same as 1 over e squared. All right, now let's do one more. Let's do log of 10 to the 5th. 10 to what power gives you 10 to the 5th? A 5. Now, all of these actually you can figure out even quicker by using some rules. Okay, so here are some log rules. They're in your book as well. Okay, if you need more time writing these down, just pause and write them down. But I want you to see here that log of any base of 1 is 0. Log where you have your base and your argument as the same number, that's going to equal a 1. All right, so log base 2 of 2 is 1, log base 10 of 10 is 1. And if you have a power on that argument, that power is your answer. Okay, likewise, if you have an exponent, a to the power of log base a of x, that x is just your answer. Let's write these log rules for natural log. So for the first one, we would say that natural log of 1 is equal to 0. For the second one, remember, we'd still write ln for natural log, and that base is implied as e. So we write of e, and that's going to be equal to 1. This next one would look like this. Natural log of e to any power would equal that power. And then the last one written in with the natural number, we'd have e to the power of natural log of x, and that would equal x. If you're good at memorizing, memorize. If you're not good at memorizing, you can figure all these out just by thinking about the relationship between logs and exponents. Okay, the last example is domain. Now, if you think back to the original problem, the domain of the parent function was where x had to be greater than 0. All right, and that was when you had log of x. Okay, now we have log, in this case natural log, that really doesn't change anything, of something more complicated than just x, but you're still going to consider that thing to be greater than 0. From here, you should be able to figure it out because you know how to do these inequalities, in this case a quadratic inequality. Okay, so to solve a quadratic inequality, first you want to solve the solutions to the equation. 4 minus x squared is equal to 0. Then if you can factor, you want to factor. So this would be 2 minus x and then 2 plus x is equal to 0. So I have a solution of 2 and a solution of negative 2. So let's put these in order on a number line. This is how you can always find domain. Okay, I do not want negative 2 or 2 to be considered as solutions to this inequality. For log, it'll never be greater than or equal to 0 like it was for square root. It's just greater than 0. There's an asymptote, you know, where this graph starts, so to speak. Okay, so we don't want it to be greater than or equal to 0, just greater than. And then we can do some test points. If I plug in a 0, I get a true statement, so I would shade in. If I plug in a number over here or a number on the right, I would get a false statement. So my domain is all the numbers from negative 2 to 2. Now let's think about this logically now. If I plug in a number between negative 2 and 2, okay, so like a smaller x, either positive or negative, doesn't matter because I'm going to square it. Okay, I will be able to take natural log of that number because it will be greater than 0. But if I plug in a number that's really big, either positive or negative, all right, I will get a negative number, and you cannot take log of negative numbers. You can only take log of positive numbers.